Good morning or afternoon, everybody. It is past hump day, so we are only 2 days away from the weekend. At this point, please turn in your homework from yesterday to the front corner, and we will go over it later when I get back. Hopefully it wasn't too confusing. When I get back, we'll actually go over the content a little bit more specifically, but I didn't think it hopefully shouldn't have been that bad. So please turn in your homework. And at the same time, can you guys please do the bell work in the front? So at this point, please pause it so you guys can turn in your homework and finish this bell work. Alright, and we're back. We talked about forces yesterday and the day before, talking about the double O research with different types of bonds. And we talked about, or you guys discovered this whole dipole force. And if we go over it, dipole force is a bond or a force between two equal but opposite charges. So two elements having a positive, one element having a positive, one element having a negative, or even within the same element or compound having a positive and negative. As long as they're equal but opposite, it's called a dipole force. And we'll do a whole lab on that next week when I can go over this a little bit more in detail when I'm there. But today we're going to go on to something else. We're going on to something very specific to chemistry, and that is going to deal with actually writing out compounds and molecular naming. So right now, let's pause this so you guys can get you can get notes out, and we can start doing this. Hopefully everybody's ready now. What we're doing is we're writing binary ionic compounds. So we're going to be taking the elements, taking their charges, and combining them together to make different compounds, as in H2O, using the element symbols to write compounds. Now the first set, so we're going to be working with binary, meaning two. So binary compounds composed of two elements. And there are specific rules that go along with this. By the way, at any time, if I'm going too fast, please somebody pause it so you are not getting frustrated at the pace. There are certain rules we have to do this for writing a compound. First off, you take the elements and you put the symbols down, and they're going to go side by side. You write the cation, which is a positive charge element, first. Most 99% of the time, the cation, the positive charge element, is going to be a metal, so it's going to be on the left hand side. It's going to be in the 1 plus, 2 plus, or 3 plus groups or columns on the periodic table. So you write that down with the positive first, and then you put the cation behind it. And then next you put the charges above the element symbols. The element's charges you should have on your periodic table, or if you're looking on the side wall, the wall has a periodic table. It has all of the periodic charges, and it's that positive or negative number right above the column. So first two things, write down the ions side by side. Then put the charges of the ion. So let's go and do an example. So skip a couple lines in your paper, and let's do the following example here. So this is example 1. We're taking calcium and combining that with fluorine. So the first part of that is, as it says in the rule, put the symbols and its charges side by side. At this point, calcium we can find on the periodic table, and fluorine we can find on the periodic table. Calcium has Ca, fluorine has an F, and their charges are Ca has a 2+ charge, while fluorine has a 1 negative charge. So that's the first part of writing these compounds. Taking the names, writing them in symbolic form, as in Ca and F, and then putting their charges in the subscript, which means up above here. So that's our example. So let's go back to our rules. Number 3. We take the charges and cross them over using absolute value. And for, I think it's in Algebra 1 or Algebra 2, absolute value is, it is only going to be positive. You can't have a negative number when we do this. So you take the two charges and you cross them. The charges, the 2 plus, the 1 minus, they become subscripts, which means they become subset numbers. I'll let you finish this and we can go look at their example. And if this hasn't been a long enough time, please stop this so everybody has this so we're not being lost. Going back over to our example of calcium fluoride, we're actually making a salt formation right now with these two. These two combine a type of salt. We don't use it in cooking, but we do use it on the roads during the winter. So when we talked about crossing the charges, let me get my arrow here. So we're going to take the 2, cross it down here. We're going to take the 1, cross it over here. So we're taking the charges, we're taking the numbers only and crossing them. The charges turn into the subscript for the ions. And we'll get to this in just a second. We'll go back to this one. So the final compound for here, for calcium and fluoride, or fluorine, is Ca1F2. So the 1 right up here so that 1 that was up here, even though I made it look really dark, that 1 crossed over and is now the 1 right here. The 2 is now the 2 over here. Now since we're writing compounds, we don't need charges. So those charges, those positive and negatives, do not count. We just get rid of them. So we're just taking the numbers, crossing them over, and this is our final answer. Ca1F2. Now sometimes we got to look at rule number 4. Check the subscripts and divide them by their largest common factor to give them the smallest possible whole number ratio of ions. So I'll let you write this down and we'll get back to it in just a second. So let's move on once again. Please stop it if you guys are not done with this yet. Let's do an example for rule number 4. Let's do magnesium and oxygen. Please try this together. Pause the video and try to figure out the chemical compound of magnesium and oxygen when combined together. So please pause. We're back. We should have the symbols for magnesium at Mg. Mg, as we know, has a 2+ charge. I'm going to put this in a subscript. So that's our magnesium. Our oxygen has 2, and the charge is 2-. Let's make this other one bigger too. Whew. So for this, what we do is same thing. We wrote the charges, we wrote the symbols. Now we cross them. And we rewrite it so we're only left with the numbers as subscripts, or the numbers on the bottom, and the charges go away. Mg2 back this up O2. We can make these subscripts for me, make them smaller. Now as you see, we have this Mg2O2. That's the formula for magnesium and oxygen when they combine together. But as rule 4 says, check the subscripts and divide them by their largest common factor to give them the smallest possible whole number ratio. Which means reduce the numbers on the bottom if you can to make it the simplest formula. As we know, 2 and 2 can be divided together, or divided by themselves. So the simple way of writing magnesium and oxygen is MgO. And your final answer is MgO. Now, will I count you guys down if you put Mg2O2? No. But for you, when you get doing the larger ones, it's going to be much easier if you guys, if you can eliminate some subscripts, to eliminate some subscripts. So that's how we write binary ionic compounds. Please work with your niche mate to answer the following ones: calcium and sulfur, strontium and chlorine, and aluminum and phosphorus. I will put the answers up online, and I will also give you guys your homework up online as well once you finish with this video. Have a great day, and you guys will be able to watch the other video and once you get done with this.